All right, so now we're going to talk a little bit about stoichiometry because you knew it was coming. We've been doing stoichiometry with gases, we've done it with solids, now we're going to do it with solutions. So a lot of reactions take place in aqueous solutions. In this one in particular, we're going to be talking about precipitation reactions where a solid is formed. We're actually going to do a lab with this. It's a very, very common thing to do in chemistry. So it's possible to use the process of stoichiometry to determine the amount of products that you get or the amount of reactants you get using that molarity thing. Because remember, molarity is moles over liters, and moles are what we need to do stoichiometry. So if we can work our numbers around and figure out how many moles we have of something, we can do an awful lot with that. So molarity is moles over liters, and if you remember, stoichiometry involves changing from the amount, and it doesn't matter if it's grams or particles, or in this case, molarity, or if we're doing gases, liters, the amount of one chemical you have to start with to the amount of a different chemical. And it doesn't necessarily have to go to reactants to products, although most of these will. So the steps in solution stoichiometry is, just like always, you got to have that balanced equation first. And I know it's been a while, but you guys probably remember how to do that. And then you will be given either the liters or the milliliters. And remember, 1 milliliter is 1e negative 3 liters. You're going to need to use that conversion possibly. And the molarity of a given substance, and asked to find the amount of a different substances. And often it's going to be grams. Not always, but often it will be. So what you're going to do is you're going to start with liters. That's why I say you're going to need this conversion. And you're going to convert to moles of whatever it is you're starting with. Okay? Because molarity times liters gives you moles. And then you're going to use the balanced equation to convert from moles of the starting chemical to the moles of the desired substance. Remember, this is where you're going to use the coefficients. And if you don't do this step, you're not doing stoichiometry. And then you're going to convert the moles of the desired substance in whatever they want. Like I said, most often it's going to be grams if we're doing precipitation stoichiometry, but it could also be particles. Just a matter of what they're looking for. So this is what it starts like. You're going to start with however many liters they give you in the problem of a solution. And then you're going to put liters on the bottom, and you're going to put molarity on top. And so this is a little bit different than what we've been doing in the past. In the past, we've always written a 1 by the word mole. Here, when you're doing molarity, you put the 1 by the liter. It's a little bit different. So you're going to use the molarity of the given solution, and then you're going to use the balanced equation to change from one chemical to the next. And then, like I said, most of these are going to involve finding grams of your solid product, whatever it is, using molar mass. So it's a bunch of different steps, but it's just adding an additional step to the stoichiometry we've been doing all along. Shouldn't be too difficult. So first things first, let's balance this equation. Go ahead and see if you can do it. Pause the movie, and I will put the answer up. Looks to me like that's probably it. Yep. Okay. So what mass of solid precipitate? So first of all, you've got to figure out what the heck are you solving for? Well, you're looking for the thing that is the solid. That would be the AgCl. Can be made by the reaction of 1.5 liters of AlCl3. Notice I wrote down the number, the unit, and the chemical. It's a good habit to have. So 1.5 liters of AlCl3. Remember, when it says excess, we're just going to cross off excess silver nitrate. Okay, that's an old habit. When you ever see excess, you can just cross it off. We're going to put liters on the bottom. We're going to put moles on top. That's your molarity. And the thing is, when you're using molarity, you're going to put a 1 by the liter. And that 0.125 goes by the moles. That's what makes it a little different. Then you're going to do the middle step where you change from one chemical to a different chemical. And in this case, we're going to do AgCl because that's my solid. And you're going to look at the balanced equation. There's one of these and 3 of those. AlCl3 cancels out. And then in the last step, they want the mass. That means they want grams. So you're going to put moles on the bottom, grams on top. And because it's not molarity, you're going to put a 1 by the word mole. If it's molarity, you put the 1 by the liter. But if it's moles and grams, you're going to put the 1 by the word mole. You're going to add this stuff up, and you get 143.4. So moles cancels out. Oops, AgCl you keep, though. Go ahead and do all the math. 1.5 times 0.125 times 3 times 143.4. And I got 80.7 grams of AgCl. So it's just adding another step to stoichiometry. This stuff you guys should already be familiar with. You should already know how to use the balanced equation. You already should know how to use molar mass. The thing that makes it a little different is we've got this molarity thing going on. And remember, if it's molarity, you're going to use 1 by the liter, not by the mole. All right, so go ahead. Same balanced equation. I want you guys to try this one. Again, there's a 3 here and a 3 here. And again, with excess, we're just going to cross that sucker right off. We don't need that at all. What mass of precipitate can be made by reacting 75.3 milliliters of 0.5 molarity AgNO3. So again, we're still looking for our solid. Every time when it says precipitate, that's what they're looking for. So start with the liters. Well, I don't have the liters. So what I'm going to do is I'm going to start with 75.3 milliliters, and I'm going to do that conversion as my very first step. Milliliters is gone, and I'm not even going to solve it, because you know what? I'm just going to continue on and go into the next step, which is liters on the bottom, moles on top, and again, this is molarity, which means you put a 1 by the liter. And then you're going to use the molarity value, 0.500, goes there. Okay, so notice I didn't even stop to solve the milliliters to liters. I just build it right into the problem. I'm starting with AgNO3, so the AgNO3 goes on the bottom. There's a 1 by it. Oh, sorry, I lied, a 3. And then AgCl goes on top because that's my solid. That gets a 3 also. And then the last step, they're looking for mass. That means grams. So we're back to that 143.4 and 1 mole. So it's basically just kind of doing what you guys have been doing all along with an additional step that is a little bit weird, granted. That 1 by the liter, I know that's not like a habit that you guys have developed, but you kind of have to get used to that. 5.40 grams. Okay, so it's just adding this extra step and possibly this step if it's not given to you in liters. But the ending part of it is going to be pretty much the same all along. So go ahead and see if you guys can do this one. We're throwing back to some old stuff here. Let's balance this equation. We'll put a, let's see here, put a 3 there, and a 3 there, and a 2 here. And that should balance it. Okay, so what mass of precipitate, that would be the solid stuff we're looking for, can be formed by the reaction of 92.5 milliliters of this with that. Guess what this would be? This would be a limiting reactant problem. Okay, but it's done exactly the same as all the limiting reactant problems we've been doing all along. Start with your volume. We're going to change from milliliters into liters. And then we're going to change from liters into moles. And again, that's molarity. Put a 1 by the liter, 1.75 moles. Calcium chloride is 3CaCl2 from the balanced equation. And you're trying to find your solid, so that's the 3CaSO4. And then the last step is 1 mole into grams, because they're asking about mass. Like I said, most of these are going to be asking about mass. 136.2. And then you're going to do the same thing with the other reactant, because we don't know what's excess yet. So 95.3 milliliters. Milliliters on the bottom, liters on top. 1E -3. Liters on the bottom, moles on top. Again, put a 1 by the liter. 1.45. And it's 1 Al2SO4 3 for every 3 of the calcium sulfates. And then the last step, it should be identical to the one above it, because you're changing it into the same thing. That's how you do limiting reactants. What you want to do is make sure that you are comparing the same chemical. So when I do this, I get 22 grams. And for that one, I get 56 grams. So if you remember back when we were doing limited reactants, the one that limits how much you get is the one that you end up choosing. So 22 grams is less than 56. That means this is my limiting reactant, is the calcium chloride, because it only allows me to make 22. Even though I could make 56 with my other reactant, it only allows me to make 22. Okay, so go ahead, take a minute, and see if you guys can practice this one. Same balanced equation, 3, 3, and 2. Go ahead and set it up. It is a limiting reactant problem because you have both reactants. It doesn't say excess anywhere. Start with the milliliters. change it into liters. And again, you're going to use that molarity thing. Liters on the bottom, moles on top. And in this case, it is a 1, but that's because of the 1.00. I'll put that in there. And then it takes 3 calcium chlorides to make 3 calcium sulfates, because again, we're looking for our precipitate, which is this guy. And 1 mole, and it was 136.2 from the previous slide. Do the exact same thing, 200 milliliters. One liter, and it's 0.5 moles. 1 aluminum sulfate, 3 calcium sulfates, 1 mole, 136.2 grams. And then all you do is literally run through the math and pick the smaller number. So that's 20.4. And that's 40.9. So, whoops, go back. Grams. So that's my answer, because this is my limiting reactant. Okay, so it's not that hard. It's just adding that one extra step where you're doing molarity. And what I want you to write is I want you to write 1 liter if you're doing molarity.